Special cases are found in equations with variables on both sides. So to solve these special cases, we still have multiple steps, right? So we're still going to ask ourselves the questions, do I need to distribute? And it might be, yes, I need to distribute, or no, I do not need to distribute, right? And then we ask ourselves, do I need to distribute? What's the second thing you have to look for? Combine like terms. So for multi-step equations, so there are variables on both sides in a special case, we still look at this problem and we say, do I need to distribute? Do I need to combine like terms? Both of those things are to simplify the problem. Both of these, distributing and combining like terms, always distribute first and then combine like terms if necessary. Those are to simplify. Those are to make the problem easier. And then I'm going to fill in the next 3 steps. So step 3 is to move the smaller variable. Once you move the smaller variable, then what's step 4? Move the constant. And what is a constant? The number by itself. And then once you move the constant, step 5 is move the coefficient. However, when it comes to multi-step problems with special cases, you're going to distribute, you're going to combine like terms, but once you get to step 3, this is where it all gets a little wonky. Did you see my fancy highlighter? Yeah. I know. You guys. It's a game changer. Step 3 is where we throw a wrench in the system. This is the game changer today. I mean, we're still, every time you have an equation, you should ask yourself, or you should go through these 5 steps. Except, you're going to see on these special cases today, you can't go through these 5 steps, because when it's a special case, once you get to step number 3, you're going to encounter a problem. You are going to encounter a problem. So let's just dive right in.
Oh yeah.
Okay, so negative 6 minus 3 times the quantity 5 minus m equals negative 24 plus 3m, right? So this is obviously a multi-step equation, correct? I mean, it's got lots of stuff. Doing this mentally is a challenge, so we're going to go through our steps.
Oh really? Okay.
Got it. So first thing we're going to do is ask ourselves, do I need to distribute? And the answer is yes, because there are parentheses. So I'm going to have to distribute. So I'm going to take that -3 and distribute it to the 5 and to the -1m, correct? Because there is a number there. It's just not shown. So does this -6 at the beginning of my problem change? No. -6. And then -3 times 15 makes -15. Right? And then -3 times -1m makes +3m equals -24 plus 3m. Do you agree? Okay. So I distributed. Check. Now I'm going to, step 2, combine like terms. Is there anything that needs to come together? -6 minus 15, correct? -6 minus 15 makes -21 plus 3m equals -24 plus 3m. So I did step 1, which was to combine, or no, to distribute. Then I did step 2, which was to combine like terms. Now I'm on to 3, which is move the smaller variable. And then I would move on to 4, which is move the constant, and 5, which is move the coefficient. But I told you 3 is where it gets wonky. Because I look at this problem now, and my variable on the left is +3m, and my variable on the right is +3m. And it says move the smaller variable. And what can you tell me about these two variables?
They're equal.
They're the same. They're equal.
Oh.
So if I move, doesn't matter because they're both the same. If I move this +3m by subtracting 3m, correct? And I do the same thing over here, -3m. I'm left with -21. These cancel out. Equals -24. And these cancel out. And is this a true or a false statement?
False.
This is a false statement. -21 does not equal -24. This is a false statement. That is not true. So the answer to this problem is no solution. There is no answer, no number that would work for m to make the left side equal the right side. This problem has no answer. Because I distributed, I combined like terms, but then I get stuck here. I need to move the smaller variable, but the variables are the same. So I just pick one to move. And when I move the smaller variable, my variables disappear, and I'm left with a false statement. And since it's false, there is no solution. There is no number that I could say m equals blank. No decimal, no negative, no positive, no number that would work for m in this problem. So this equation has no solution. There is no answer to this problem. Henry.
So like, how it says -21 and how it doesn't equal -24, if they were both like -21 or -24, then you could put any number for 3.
So let's see. 7x plus 35 equals 7 times, oops, my x turned into a v, x times times 5? Plus 5. All right, so again, is this a multi-step problem? Yes. Do I need to distribute?
Yes.
Yes, I'm going to take this 7 and multiply it by x and multiply it by positive 5. 7 times x is 7x. 7 times 5 is 35 equals 7x plus 35.
That just satisfied my OCD so hard. I'm not even
So then I ask myself, do I need to combine like terms? No, there's nothing alike at this moment. Then I say step 3, move the smaller variable, because I do have variables on both sides. But which one's smaller?
Neither.
They're both the same. So I'm going to subtract 7x and subtract 7x. That cancels out. And I have 35 equals 35, which is a true statement, right? So this solution is all real numbers. This answer, if I was going to say x equals, you could pick any number that you know of. X could equal pi. X could equal radical 2. X could equal 7. X could equal negative 8. X could equal 1,732. X could equal 0.0000003. Any number you can think of at this moment would work for this. Now, it's not all numbers. It's all real numbers. I should put an S on there. There are these things called imaginary numbers that you will learn about in Algebra 2. Those would not work. But right now, the only thing that you are aware of are called real numbers. Every number you can think of is a real number.
Can you briefly go over unreal numbers?
No. So, all real numbers. Some people also say I switch between it. Sometimes you'll see infinite solutions. All real numbers. Sometimes some websites, some places will say infinite solutions, meaning that there are infinite answers, right? All real numbers is best because there are some numbers that do not work. We just don't know them yet. So, here's my disclaimer about special cases. There's a reason we teach this last. Special cases, once students learn about special cases, they tend to say, oh, that one's just no solution. That one's all real numbers. That one's no solution. And they start popping up everywhere. Most of the time, you're going to have a solution. Okay? Most of the time, there will be one answer. There is one solution to the problem, x equals blank. Occasionally, you'll have a no solution. Occasionally, you'll have an all real number. Okay? Do not just be like, you know what? I'm just going to 50-50 this. That's not going to work out well.